Hey everyone, this is lesson 2, operations with radicals and rational exponents. We're going to kind of use just the word radicals as an umbrella expression for both, because remember, you can convert back and forth. They mean the same thing. So how do you perform operations with radicals and rational exponents? Being able to simplify expressions by performing operations with radicals and rational exponents, using those rules of exponents, figuring out what like terms are, factoring things down, all of those are objectives for this unit. So like terms is something that you learn fairly early on in your math career. So looking for the variables or the terms, remember terms is separated by plus or minus, terms with the same variables and same exponents. So your 5x, 5x, 6x squared, negative x squared, and that's it. So by combining those, you end up with 2x plus 5x squared plus 7 minus xy. So looking for those like terms. Like radicands or like radicals have to have the same radicand, remember that's the number underneath, and the same index. They have to have both. So up here, same variable, same exponent, same inside number, same exponent, essentially, same index. So here we have 5 root x. Over here we have a negative 6 root x, so those are like terms. We have a negative 2 root y and a positive 2 root y. Those will end up canceling. And I see one more here. We have a 6xy and then an 3xy here. So 5xy minus, or 5x root x minus 6 root x is negative 1 or just negative root x. So when we add or subtract these, only the coefficient changes, which if you look up here, it's the same rule. Okay, so negative root x, these cancel each other out because they are identical, and then we have 6 root y plus 3 root xy is 9 root xy. All right, so last lesson we talked about the product rule and the quotient rule. I want to make sure you don't get those mixed up with addition and subtraction. So here we have x plus y and root x plus root y. I want you to see here that if I do these, will you get the same result if you split them up? So root 25 plus 100 is the same as root 125, which is equal to 25. Where over here you have the square root of 25 plus the square root of 100, which is the same as 5 plus 10, which is 15. And hopefully it's pretty clear that 25 does not equal 15. So you cannot break apart pieces and do these piece by piece when you are adding or subtracting. So same as with the last unit with our fraction rules, remembering what those rules are with real numbers and then applying those to variables. So here we have square root of xy, square root of x, square root of y. We talked about this last time. This is your product rule. This is square root of 36, which is 6. This is the square root of 4, which is 2, times the square root of 9, which is 3. 2 times 3 is also 6. So that is fine. We can break those apart if it benefits us. We'll put them together if it benefits us. So whatever helps us. All right, so remember your domain is a list of what x can be. So here you have that 2 as your index, which is an even number, which means that you can't have a negative underneath your radical. I just used the symbol, which means that x minus 2 needs to be greater than or equal to 0, which means that x needs to be greater than or equal to 2. So this is your domain value. Interval notation for that would be 2 brackets, sorry, it's included, to infinity. So anything above 2 is fine. So this is your domain. For an odd index, the number underneath doesn't matter. So it can be both positive or negative. Right? So the domain for odd index is always just all real numbers. We don't care what that x value is as long as it's a real value. We could plug it in, we could get a square root, and it will be fine. Or a cubed root, excuse me, or fifth root or whatever the odd number is that you're taking the root of. Okay, so even domains, you should actually have a domain of some sort. Odd, all real numbers. Okay, so for this next section, assume all variables are positive for both sections. This direction just means you don't have to worry about the signs for your variables. So really not even necessarily something you need to write down. You're just going to treat every variable like it's positive. You're not going to worry about like absolute value or anything like that, like we talked about last unit. So remember, in order to add or subtract, that is a really bad 3, you have to have the same index with the same radicand. So right now, as these are, they're not the same. So they have the same index. We've got one of the two, but we don't have the second must that we have. So you may have to simplify first in order to see if you can actually combine them. So here, cubed root, I know that 8 goes into 24 3 times. Goodness, don't know my multiplication tonight. And that y cubed is a perfect cube. So this is 2y times the cubed root of 3x. So I took my perfect cubes out. I left my non-perfect cubes in, minus 81 is a perfect fourth, which means that it has 3 of something. So 3 times 27. 27 is a perfect cube. So the cubed root of 27 is 3. There's a y cubed root of whatever's left. So 3x. Now, if you look at what you have, we have the same index and the same radicand, so the same radical, if you would, which means that we just need to combine our coefficients. So 2y minus, watch your signs, minus 3y is negative 1y or negative y times the cubed root of 3x. So add or subtract, simplify, combine, like radicals. Okay, so make sure they are the same before you combine them. With multiply, I would multiply first. Then simplify. That way you're not simplifying twice, because sometimes you simplify, you distribute, and then you're able to do it again. So the general rule when multiplying, and we haven't done this yet, is that you do inside number times inside number, outside number times outside number. We never mix and match. And if you go back to thinking about what a root means and what a radical symbol means, then that would make sense to you. If I go up here, for example, I have this simplified. Let's just use 24. The cubed root of 24, when I broke that down, I have the cubed root of 8 times the cubed root of 3. Well, this is 2 times the cubed root of 3. This, though, if I just distribute this back in, is the cubed root of 6. Well, that's not the same as the cubed root of 24. So when you are multiplying, this is why we stick to inside, inside, outside, outside. We can't just take a number back inside of a radical. We already simplified it. So that being said, we're going to take this and we're still going to distribute it all the way through to both terms. So 2 times 1 is 2. 5 times 3 is 15. Plus 2 times 3 is 6. And 5 times 10 is 50. So now we need to simplify so we can see if we can combine. Well, this is 3 and 5. That's it. That one doesn't break down. But 50 is 25 times 2. So we have 2 root 15 plus 6. The square root of 25 is 5, so times 5 root 2. And then last step, just simplify that. And we're done. One of these days I'll record a video without making mistakes. I was looking back through some stuff and noticed this. So if you want to go back up here, I didn't finish this. I wrote 25 and just stopped. This is 25 times 5, which means that this is 5 root 5. So, which is still false, but it was just the point. 5 root 5 does not equal 15. Sorry about that. Okay, next example. Same type of deal here. We have the square root of a times the square root of a minus 3a. The reason that this is on here is because I want you to think about what's going to happen when I take the square root of a number times the square root of itself. I'm still going to distribute this all the way through. So you have the square root of a squared, because you're going to multiply inside times inside, minus 3a root a. Those don't combine in any other way. They're not the same. But this becomes a minus 3a root a. And that should always happen. This right here should always happen. Anytime you multiply something times itself, so square root of 5 times square root of 5 equals 5. Square root of 7 times square root of 7 will equal 7. Because remember, it's the opposite of squaring. So A times A is A squared. 5 times 5 is 5 squared. And then I take the square root of that. Okay, so just make sure you're thinking about that as you go through. This one, do not distribute the exponent when there's plus or minus. Okay, we cannot do that. Do not do that. Don't even put it on your paper. You don't actually do it. Goodness. Okay, so 3 root A plus 2 squared means that I'm doing 3 root A plus 2 twice. So this is a FOIL distribution problem. It will work the same way. We're going to take this first term times this whole first term, inside with inside, outside with outside. So applying the rule I learned up here, root A times root A is just A. If you want to write that as 9 square root A squared, and simplify here in a minute, that's fine. Then you take first times second. So again, outside, outside. So this is plus 6 root A. This will create a perfect square trinomial. So these two will actually end up matching, plus 6 root A. And then your very last term, 2 times 2 is 4. These are like terms. So 12 root A, only the coefficient changes. Everything else comes down. Sometimes you'll have more like terms that you can combine, especially if like this isn't a letter, but it's a number. Then you'll end up having those outside terms that are the same. But other than that, that's all we can do for that one. Okay, this next section, I'm just going to kind of briefly cover, especially for those of you that still have the ACT to do. There's a common practice to not leave radicals in the denominator. And depending on your calculus teacher, when you get to that level, they may require it. The ACT, all of the answers presented will be rationalized. So to remove them is called rationalizing the denominator. And it's just the process of getting rid of any radical symbol, any root at all that you have on the bottom of a fraction. And we can utilize this rule up here to do that. Sorry for the bad handwriting. Okay. So knowing that when you multiply something by itself, it comes out as a whole number value is what helps us to rationalize our fractions. So you're going to multiply both the top and the bottom by square root of 5, because that's just like multiplying by 1. So now we have the square root of 30 over 5. 30 is 6 times 5, which is 2 times 3 times 5, so that doesn't simplify, and we're done. Okay, remember we can't simplify 30 over 5 because one is inside the radical and one is outside the radical. Cubed roots are going to work the same way, except for, remember, to get a whole number value, we need a group of 3. We need to match that index. So always start rationalizing problems if you can't simplify them by breaking them apart, because the only thing that we need to get rid of is this radical off the bottom. So to do that, we have to multiply it by the same index. We can't mix and match indexes. But we also need to make sure that when we multiply these two values, we get a number that will help us cancel out our index. So we have 1, we need 2. So I'm going to put y squared because 1 plus 2 is 3. 3 divided by 3 is 1. So that will help me get rid of my radical. Okay, so this makes this the cubed root of 4xy squared over the cubed root of now y cubed, which is the cubed root of all of that, over y. Okay, so making sure you give enough to create a perfect root. So something divisible by the index as far as like your exponents go. Don't mix up horizontal division with vertical. This means the same thing as the square root of 32 x cubed divided by the square root of 48 x squared. We can rewrite this all under one radical if it will help us a little bit here. So 32 and 48 both reduce by 16, so we can go ahead and reduce those. So that is 2x cubed over x squared is just x. 3. And then we could pull that back apart. So now we have the square root of 2x over the square root of 3. So to rationalize, we need a root 3 on the bottom because root 3 times root 3 will utilize that rule. So now I have 3, and on top I have 6x. All right. Other ways to do that, that's going to be probably the easiest because then you're working with a much smaller number, not having to simplify any fractions or radicals when you're done. So just like with regular fractions, if you can go ahead and simplify it before you do anything else, then do that. Okay. When you're dealing with variables and different indexes, remember that we need something divisible by 3. So our index here is a 3. We need our exponent to be divisible by 3. So I'm going to multiply here by y to the second because 10 plus 2 is 12. And 12 is divisible by 3. But if I do that on the bottom, I have to do that on the top. So now I have the cubed root of x 4 y squared over y to the 12th. So then I can break that up, the cubed root of x 4 y squared over, and you can, like I said, you can go ahead and write out the cubed root of y12, or just know that this is y now 4. 12 divided by 3 is y4. Up here, we do need to simplify. So we have x to the 4th that has a group of 3, so an x comes out. Now I have the cubed root of a remainder of 1, y squared. So this is 3 plus 1. So remainder of 1 stayed in over y to the 4th. Okay. The last thing we really need to go over is a problem like this, where you have addition, because remember, I can't just take 4 over 2 plus root 8 and multiply this by root 8, because then this would have to distribute through. So the only thing that accomplishes is moving my radical from one term to another. Okay, so it does nothing. So instead, I'm going to multiply by something called the conjugate. And there's like a little chart in your textbook if you want to refer to that. But essentially the conjugate is the same two terms with the opposite sign between them. They're not both going to switch signs. That doesn't do any good either. So you get a difference of squares. So you remember your difference of square pattern. If you have x plus 1 times x minus 1, that's equal to x squared minus 1, where they're both perfect squares. Well, if both of these end up perfect squares, there's no more radical, because when you square a square root, it goes away. So the conjugate for 2 plus root 8 is 2 minus root 8. I'm going to do that on bottom and top. Sometimes you have to FOIL the top, so make sure you pay attention to how many terms they are. So this, though, is just 8 minus 4 root 8. We'll simplify that in just a second. I'm not going to worry about it yet. Over. Now, when you're doing this, and I'm going to show you all the way out real quick. So 2 times 2 is 4. Here we have minus 2 root 8 plus 2 root 8, and then minus 8. Okay. The whole reason we did that is because these should cancel. So make sure that happens. If you're confident, you could even just skip straight to the 4 minus 8 and just know that those middle two terms will be gone. My only concern with that is if you accidentally mess up and then still assume it's going to happen, then it won't. So a couple things left to do on this problem, and that is to break this down. This is 4 times 2. So the square root of 4 comes out. So 8 minus 4 times 2, square root 2, over negative 4. So 8, goodness, I'm having trouble with my 8. 8 minus 8 root 2 over negative 4. Everything divides by negative 4. Remember, you can't divide inside a radical, so we're just looking at those outside numbers when I say that. So all of these divide. And so 8 divided by negative 4 is negative 2. Negative 8 divided by is plus 2, root 2, and done. Okay. Lesson 2 homework assignment should be posted on Schoology. Make sure you look for that lesson 1 discussion board and answer the prompt. Have a good night.